Hello everyone, welcome to Senior College Mathematics. Topic of discussion is indices. If you are in senior college, you are preparing for WAEC, for NECO, for GC, for NAPTEP, for JAMB, or any other external or entrance examination into high school, this lesson is for you. Lesson 5, Application of the Laws of Indices 2. So lesson 5 is continuation of lesson 4 in relation to lesson 3, where I taught laws of indices. Examples: simplify the following. Before that, for updates, follow Voice of Peter course via YouTube at Peter Course Simplified Maths. To do that, subscribe to this channel, like this video, share it to your friends, your colleagues, your classmates. You can also follow Voice of Peter Course via Facebook, Instagram at Peter Course Simplified Maths. For questions and inquiries, use the comment section. We attend to all of them. Example 38. You should simplify, bracket open, 64 over 125, bracket close, to the power of minus 1 over 3. This is the second version of the negative index. When you have a fraction raised to the power of a negative number, that is 1 over 3. What we'll do here is to do away with the minus sign. You simply interchange the position of the numerator and denominator in the fraction. So you have 64 over 125 changed to 125 over 64. As you are doing that, the power that is negative here becomes positive. It's as simple as that. 1 over 3 means cube root. So you take cube root of 125 over 64, and that gives 5 over 4. Or after interchanging and you have it this form, to take away cube roots, you need cube, that is power of 3, from 125 and 64. To achieve that, you express 125 as 5 cube and 64 as 4 cube. So by power law, the power 1 over 3 multiplies 5 cube and 4 cube in this form. 3 times 1 over 3 is 1. So you also have 5 over 4 remaining. You see that? Okay. Example 39. You have square roots, bracket open, 125 square, bracket close, to the power of 1 over 3. Let's apply the power law first, where the two powers, 2 and 1 over 3, multiplies themselves in this form, and you have 2 over 20, 2 over 3, 2 over 3. Okay, we are seeing 3 there as cube root. No, if you factor out 2 now from the power, you have 1 over 3, that is cube root. So to remove cube root, let's express 125 as 5 cube. So you have 5 cube, because we are aiming at removing that 3 in the denominator of the power. So we must express 125 if possible, such that the power will be 3, and that is 5 cube. If you apply power law again, you multiply 3 by 2 over 3, that is 6 over 3, and you have 2, so you have 5 cube. 5 square. You have 5 square. If you take the square root of 5 square, you have 5. Or you can look for 5 square, that is 25, and the root of 25 is 5. Are you following? Okay. Example 40. We have this expression: 49 power of half, 3 power of 0, 4 power of 3 over 2. Okay, 49 power half means roots, so you have root of 49. From 0 index, 3 power 0 is 1. Looking at the third term, if you factor out 3 from where it is now, you are left with 1 over 2. That means root. So you have root 4 to the power of 3. The power of 3. Root 49 is 7 times 1. Root 4 is 2. Then the power of 3 affects 8. So 2 cube is 8. 2 cube is 8. Then times 7. That is 56. So there is time is 7 times 8. So let me add that. Okay, so you have 7 times 8 equal to 56. Okay. Example 41. You have square root of one whole number, 9 over 16. So we have to convert the mixed fraction to improper fraction. Then we'll know what to do from there. So how do you convert? You start with the denominator 16, multiply by the whole number 1, that is 16, plus numerator 9, so you have 25 over 16. And if you take the square root, you have 5 over 4. If you convert back to mixed fraction, you have one whole number, 1 over 4. 1 over 4. Okay, so this one is the simplest so far. Example 42. Example 42. You have 1 over 3 to the power of minus 2. Okay. Here you just need to reverse the negative index. You know, assuming we have 3 like this to the power of minus 2. To remove the minus, you write the inverse. Now that the inverse has been written already, if you take 3 power of minus 2 up, it becomes positive. And this is what you have here. So 3 square is equal to 9. Is equal to 9. Okay. So example 43. You have the cube root of 4 to the power of 1.5. So we start with the inner power of 1.5. So let's convert it from decimal to fraction. So 1.5 can be written as 15 over 10. 15 over 10. Now let's convert cube root to the power of 1 over 3 in this form, so that we can apply power law. So are doing that, we reduce 15 over 10 to 3 over 2. When 5 divide, you have 3 over 2 times 1 over 3, the outer power. When you do that, 3 cancel 3, this 3 cancel 3, you are left with 4 to the power of 1 over 2. 1 over 2 means square root of 4, and that is 2. Simply 2. Okay. Okay. Example 44. You have the cube root of 8a to the power of minus 6. 8a to the power of minus 6. So quickly, this is the given problem. So we change cube root to the power of 1 over 3. Okay, the power of 1 over 3. By power law, 1 over 3 affect 8 and 8 to the power of minus 6. I know the way 8 is standard, the power is 1. So 8 power 1 times power 1 over 3. You have it in this form. Then 8, then 8 to the power of minus 6 times the power in this form. 1 over 3 means cube. So cube root. 1 over 3 means cube root. Cube root of 8 is 2. Cube root of 8 is 2. Then a power minus 6 times 1 over 3. That is power of minus 2. To take away the negative from that power now, you write the inverse. And the inverse is simply 1 over a square. 1 over a square. When you multiply, 2 times 1 is 2 all over a square. So that is the result you have for simplifying that index problem. Okay. Example 45. You have this expression: 2s power half times 3s to the power of minus 5 over 2. You can do it in two ways, but let's do the simplest one. Because we have the same base number s and s, instead of converting the power of minus 5 over 2 to positive, we can simply just add the powers directly and do that in the final answer. So this is the problem now. So let's multiply the numbers together. 2 times 3, that is 6. So for s, because the two bases are the same and they are multiplied, we add their powers in this form. That is 1 over 2 plus bracket open minus 5 over 2. If you open the bracket, you have it in this form, because plus times minus is minus. Now 1 over 2 minus 5 over 2, that is minus 4 over 2. If you divide, you have minus 2. What I was saying now. So let's do that at the last stage. To take away the minus sign, you write the inverse of s to the power of minus 2. It becomes 1 over s squared. That 1 in the numerator times 6, you have 6 over s squared. 6 over s squared. Okay? 6 over s squared. All right. So let's take 46. You have 2s in bracket power half, 2s cubed in bracket power 3 over 2. Okay, so if we take power law first, we write the first one as 2 power half, s power half. You are not new to this. Then the second term, you have 2 power 3 over 2. Then you have s power 9 over 2, because s cubed, that is 3 times 3 over 2. You have 9 over 2. We have the same basis, 2, 2, s and s. So the powers are added in this form. Then for s also, we add them. So when we add for 2, you have 2 to the power of 4 over 2. That is 1 over 2 plus 3 over 2. Then if we take for s, 1 over 2 plus 9 over 2, you have 10 over 2. Okay, so the result becomes 2 squared s power 5. When you divide 4 by 2, you have 2. Divide 10 by 2, you have 5. And 2 square is 4. So you have 4s to the power of 5. To the power of 5. Okay? Example 47. Okay, we have this problem in this form. 9 to the power of minus half over 27 to the power of 2 over 3. To take away the negative sign from the power, if you write the inverse, it means that term is coming down to join the denominator in this form, and you have 1 left. Okay, so this decide to factor out 2 so that we can see the cube root clearly. Cube root of 27, then this remains as 9 power half. Cube root of 27 is 3. Then the power of 2 at this outside affects 3. Square root of 9 is 3. 2 square is 9 times 3. And you have 1 over 27. 1 over 27. Okay? Example 48. You have bracket open, 1 over 4, bracket close to the power of minus 1 whole number, 1 over 2. The power is negative mixed fraction. So let's change the power first to improper fraction. You have 3 over 2 negative. To take away the negative sign, since this place is fraction, you apply the second version of negative index, where you interchange the position of the numerator and denominator. If you do that, you have 4 over 1. The power is positive. See that? So let's factor out 3, so that for us to see 1 over 2 as root properly. Divide 4 by 1, you have 4. So you factor out 3, you are left the power of 1 over 2, the power of 3 affecting everything. 1 over 2 to 1 over 2 as a power of 4 means root 4, and root 4 is 2. Then this power that is outside affect the result from the inside. So 2 cube is 8. 2 cube is 8. Okay? Example 49. We have 27 to the power of 1 over 3 over 16 to the power of minus 1 over 4. This negative power needs to be positive. If that term were to be in numerator, if you take the inverse, it will come to the denominator. But now that it is in denominator, if you take the inverse, it will go to the numerator for the power to be positive. That is why you have this expression like this. See that? Okay. Here, we don't wish to take the cube root directly. So, to take away the cube root and the power 1 over 4, we express 27 such that the power must be 3. It is only cube that can counter cube root. So you have 3 cube. It is only power of 4 that can counter 1 over 4. So you express 16 as 2 to the power of 4. Then 4th root, the power is outside. So 3 times 1 over 3, that is the power now. You are left with 3. Then power of 4 times 1 over 4, you are left with 2. That is 3 times 2 equal to 6. Equal to 6. You know, here we vary the approach. Some approaches we take, or in some problems we take the cube root directly, while some we try to do it manually. That is expressing the base number to get that power that take away either square root, cube root, fourth root, and so on and so on. Example 50. Example 50, you have bracket open, 4 over 25 to the power of minus half times 2 power 4 divided by 5/15 over 2 to the power of minus 2. Okay, so the first part, if you interchange 4 over 25 to 25 over 4, the power that is negative becomes positive, times 2 power 4. You interchange 15 over 2 to 2 over 15. The power that is negative here becomes positive. In the first term, 1 over 2 means square root, so square root of 25 over 4 is 5 over 2 times 2 power 4 is 16 divided by now in the third term, square of 2 or 2 square is 4 and 15 square is 225. You know, in divided fraction, division sign changes to multiplication, and again we invert the fraction to 225 over 4 over 4. So if we reduce, first you divide 16 by 4, you are left with 16, you are left with 4 now in the numerator. So you have 5 over 2 times 4 times 225. If you divide 16 by 4, you have 4. Okay, from here again, you divide this 4 by 2, divide 4 and 2, you have 2 left. So we have 5 times 2 times 225, and that is 2,250. 2,250. Okay, so you can see it's step by step, step by step. Example 51. Example 51. You have a bracket open, 1 over 3, 4, 3, bracket close, power of 1 over 3 plus 64, power of minus 1 over 3, minus bracket open, 4 over 9, bracket close, power of minus half. Okay, so to continue, this negative power and this needs to be positive, so you write the inverse of the second term. You write the inverse, so the inverse takes away the negative sign. You can see it there. Because the third term is fractional, if you invert 4 over 9 to 9 over 4, the power becomes positive. Okay, while for the first term, 1 over 3 affects both 1 and 3, 4, 3. So if we express that 1 to the power of 1 over 3 is 1, then 3, 4, 3 to the power of 1 over 3 in this form. Okay, so we have everything set. We are to simplify. So if you take the cube root of 3, 4, 3, what you have is 7, so you have 1 over 7. If you take the cube root of 64, you have 4, so you have 1 over 4. If you take the square root of 9 over 4, because power of half means square root, you have 3 over 2 in this form. So we have fraction, addition, and subtraction. So you find the LCM of denominators, 7, 4, and 2. The LCM is 28. You know the rule. You divide the LCM by each denominator and your answer times numerator. So you have the LCM 28 divided by this 7 now. You have 4. 4. Okay. LCM 7 divided by 28. Okay, so let me try to rearrange that. Okay, so let's see the proper arrangement now. So you divide 28 by the first denominator 7. You have 4. 4 times 1 is 4. That is what you have here. The second denominator is 4. You divide 28 by that 4. You have 7. 7 times 1. You have 7 here. Then minus. The last denominator is 2. You to divide 28. You have 14. 14 times this 3 you have here now. You have 42. So 4 plus 7 is 11 minus 42. You have minus 31 over 28. If you convert to mixed fraction, you have minus 1 whole number 3 over 28. 3 over 28. Okay. Example 52. You have 216 to the power of 1 over 3, or in bracket to the power of minus 2. 1 over 3 there means cube root. So you take cube root of 216, and the cube root is 6 to the power of minus 2 now, the outer power. And the power is negative. To make it positive, you write the inverse. It becomes 1 over 6 square. And 1 over 6 square is 1 over 36. 1 over 36. Okay? Example 53. You have 81 power 0.25, 32 power 0.2. The power are decimal. We need to convert them to common fraction. So 0.25 is written as 25 over 100. 0.2 is written as 5 over 10. If you reduce the first power, it becomes 1 over 2, 1 over 4. Because if you divide 25 and 100 by 25, you have 1 over 4. You divide 2 and 10 by 2, you have 1 over 5. So 1 is 4th root, the other one is 5th root. To take away the 4th root, you express 81 such that the power is 4, that is 3 power 4. To take away the 5th root, you express 32 such that the power is 5, that is 2 power 5. So if you apply power law, you have 3 power 4 times 1 over 4 all over 2 power 5 times 1 over 5. 4 times 1 over 4 is 1. 5 times 1 over 5 is 1. So we are left with 3 over 2. That can also be expressed as 1 whole number, 1 over 2. That is mixed fraction. Okay. Example 54. You have bracket open 3s square y cube bracket close to the power of 5. Directly you apply power rule, where you have 3 power 5 s square times power 5 y cube times power 5. All the terms in the bracket will take the power as expressed out. 3 power 5 is 2, 4, 3. Then s, 2 times 5, that is s power 10. Y, 3 times 5, That is y power of 15. This is also very simple. So this is how we use the laws of indices to express problems involving bases and powers. Okay? End of lesson 5. Thanks for watching and learning. Watch out for more from the voice of Peter Kos. Lastly, if you are not safe, your life is in crisis. To avoid that, you give your life to the one that can save you, and that is the Lord Jesus Christ, and you confess him as your Lord and personal Savior every day of your life. If you are saved already, I tell you, big congratulations. Live righteously and be prepared, because on the last day, some will be taken and some will be left. Take good care of yourself. Stay out of trouble. Study your books. Do the needful at all times. Flee every appearance of evil. Don't defraud others to make money. Use your hands and your brain to work, and the Lord will bless you. Goodbye.